welcome to lesson 4.1. This is the introduction to functions, and we will be able to determine if a relation is a function. Before we get started with knowing relations or functions, first let's just remind ourselves what an ordered pair is. And an ordered pair looks like this, where we've got an X and a Y. So with numbers, it would be like 0, 1. That's an ordered pair. And it always goes X, Y. Just a reminder there. And that tells us where to plot a point on a graph. A relation is a set of inputs. The inputs are X and outputs are Y's. They're related to each other. It's sets of ordered pairs that are somehow related to one another. So they've got X's and Y's. It's a whole set of ordered pairs, and that's as simple as that for a relation. Some relations are functions. A function is a relation where each input, we know that's X, also later going to be called the domain, has exactly one output, or Y, and then later on that is going to be called the range. X does not repeat, and that's the most important thing I'm going to say for the rest of this video. If you don't listen to anything else, you have to know that for a function, X does not repeat. We're going to go through a bunch of different sorts of examples and things that you would see and decide if it is just a relation or if it's a function. So when we have sets of ordered pairs like this, we're going to look and see if the X's repeat. So here, remember the X's are the first number in the order pair. It always goes X, Y. So does that repeat? So here we have 0, 2, -5, and 9. None of that repeats. So yes, this is a function. The second one, we have 0, 4, 1, 4. We've got 2 4s. So no, this is not a function. X cannot repeat. So no, this is not a function. And then the last one, we've got 0, 1, 2, 3. That's good. If you look, I put this here so you could see an example and not get tricked. We've got 1 and 1 in the Y, or the output. That does not matter. That is okay. Y can repeat. X cannot. So this guy is still a function. Yes, that is a function. So X cannot repeat, but Y can. And remember, it goes X, Y every time. For a table, is it a relation or a function? Let's look at our input here, which is also X. Sometimes you'll see X, Y instead of input, output. You could see X, Y, or domain range. That will be later. So do any of the X's repeat? We've got 0, 1, 2, 3, 4, 5. Nope, they don't repeat. Function. If you see a table, if any of these guys here, the top row, were the same, that would be no, not a function. We don't care about the bottom. We only care about the top here, the X. The X cannot repeat. You see the theme here? Now we have to determine if these are relations or functions by mapping, and that's just a way to show our relations in just a different visual way to do that. So for mapping, we've got our two ovals here, and the X's or the inputs go in that first circle, and the y's or the outputs are going to go in the second, and that's how it always works. So we've got x, y, x, y, x, y. Now we take our x's, and if we remember, those are the first value in our ordered pair, and we put them in order in our x. So we've got a 0, we've got a 1, and we've got a 2. And then we take our y's and we put those in our second little oval here. And then you've got a 1, a 2, and a 3. And what we do is we take and we draw a line, an arrow, from our input to our output. So 1 or 0 right here matches up with 1, 1 matches with 2, and 2 matches with 3. This is a function. There's no two lines are not coming from the same input, so each input is only being used one time. So that is a function. Now let's look at the next one. We have 0, 1, and 0. We only write each one once when we're mapping, so we write a 0 and a 1. You may already know the answer, but bear with me here for the sake of seeing what this relation or what this mapping would look like. And then for our y or our domain, we've got 1, 3, and 2. And remember, we do want to put those in order, so we're going to put them 1, 2, 3. And then we draw our line, so 0 goes to 1, 1 goes to 3, and 0 also goes to 2. Because this input has 2 outputs, it's got 2 arrows coming from it, it is not a function. Do we see how that looks? How that's not a function? All right, let's do one more example. For our x's, we've got 0, 2, 3, 0, 2, 3. And our y's, we have 1, 1, 2. So we only need to write 1 once and 2. 0 goes to 1, 2 goes to 1, and 3 goes to 2. This is a function. It does not matter how many arrows point to the same y. We don't care if y repeats, we only care if x repeats. So this is a function. And that is mapping. Now for the graphing part, and we've got a few different kinds of examples here. For graphing, it's still basically the same. If x repeats, it's not a function. That's it. That's simple. Remember, if you only took away one thing from this whole video, that's what I want it to be. We have a test that can tell us if something is a function or not that we use for graphs, and it's called the vertical line test. And what that is if you draw a vertical line and it intersects or crosses the graph more than one time, it is not a function. So we've got more than one x, it's not a function when we draw our vertical lines, and vertical lines are up and down, remember? Let's zoom in on these graphs. So for our vertical line test, we should be able to draw as many vertical lines as we want, all of these vertical lines, right? And it can only hit the graph one time. You see how each time we do this, and normally you don't have to draw a million lines like this, but you can see the entire graph, we could keep drawing vertical lines and it's never ever going to cross this graph more than one time. It only hits it one time. So this is a function. Yep. Same thing here. You can already tell that when we draw our vertical lines, it's not going to run into that graph more than once. That's a function. But then we look over here at this circle, and we can see, look, it hits that graph twice, here and here. That is not a function. And that just means that remember, this is y, and this is x. We have two x coordinates that are at 2. So that's not a function. It hits it more than one time. Sometimes you're going to get a graph that looks like this. Still the same thing. We can still do our vertical line test, right? None of these x, so it doesn't cross more than one time. It doesn't hit 2 points. There are no two x coordinates that are same. That is a function. Now, if we had something like right here, that would make it not a function because look, vertical, oh, that's a bad vertical line. That hits it more than one time, so that would make it not a function. But for what's originally there, it is. And now this guy. This looks tricky, but it's not. We can still do our vertical line test, right? We're good, we're good, we're good. Now right here, when we do our vertical line test, we're actually okay because an open dot means not included, remember? That open dot means it's not included. This closed dot means it's included. There's only one closed dot out of these 3 dots, which means it's only included that x right here, x, is only included one time. So this is a function. Now, if we wanted this to look like it is not a function, why isn't this going away? Give me one second here. If we want this to not be a function, okay. 2 of these would have to be filled in because then that does not pass the vertical line test because this is included and that is included, so then this would not be a function. See how that works? So you can only have one x that's included here, and that's how you know if it is or is not a function. All right, so let's see if I can zoom out so you can see. We're going to do more with relations and functions, but right now we just have to determine if it is or it is not. That is all for lesson 4.1. I hope you all have a great day.